In this game, the objective is to get to the end of the maze. Unlike other mazes, you're not able to see the maze. Instead, you're able to control your character using the bow's AR frames. If you move your head around, you look in a different direction in the game. You can double tap on the glasses to send out an echolocation signal. When you send out a signal, you receive feedback that helps you estimate where walls are. You are then also able to tilt your head forward to move forwards. As you can see in the gameplay here, we have Arkin playing the game, trying to navigate the maze without having any idea of what the maze looks like or where the end is. We developed a 3D spatial imaging tool that sends out 8 rays evenly spread about the unit circle and uses raycasting to mimic echolocation. The tool marks impact along the rays, virtualizes the impact points in space, and then plays back audio to simulate how a user would hear the sounds emitted from these points.
Listening to our tool, we discovered that the human brain is able to process the echolocation signals and translate it into a visual map of the space. We tested this blindfolding ourselves and drawing what we thought the walls around us looked like after receiving feedback from the tool.
We believe this type of technology could help people with visual impairments gain a better understanding of the space around them. For the purposes of the hackathon, we decided to simulate this technology in a virtual world, where users navigate a maze with nothing but their sense of hearing. So, how did we end up here? We began by asking ourselves, what can AR frames provide to us that we can't do with something else? We realized that we could take advantage of the unique audio-focused augmented reality approach to the Bose headphones.
Once we had an idea, we split up the project into different tasks, such as learning, implementing the Bose AR SDK, and creating our echolocation algorithm, which we did by pair programming to efficiently learn from each other. We also chose our tech stack. We decided to use Unity and C# and the Bose AR SDK to build an Android game. Along the way, we further refined our idea, and we communicated to each other to reprioritize our goals. In the end, we reflected to see what we've learned and how we can further our idea in the future.
In the game world, the mechanics are relatively straightforward. You begin in a maze in total darkness. Your only tool is your computer-assisted echolocation, which informs the player of the relative location in the maze. As the player navigates the area, they encounter other types of sensory input. For example, thuds as the player walks into walls. Landmarks like ticking clocks to orient yourself. And the guiding sound to the end destination. The player uses all this information to create an auditory picture in the mind's eye of the player. After that, all that's left is to walk through the exit.
Throughout the journey of this project, we learned a lot about Unity, and getting to learn enough to build a game was very rewarding. We were also brand new to using the Bose AR SDK, and learned a lot about the different ways that the SDK can be used. We also gained new insight into how sound travels through air and through obstacles, as well as how it dissipates through space, spreading out and becoming quieter. Most importantly, we learned how echolocation can be applied to those with impaired sight. We want to explore the different avenues that our simulation of echolocation can be used to explore real-life applications. Particularly, we want to explore the potential ways we can help people with visual impairments. We also have many future extensions to expand our game as well. To let people immerse themselves in our game and experience our echolocation, we hope to add more features, such as monsters, that will chase around the player whenever the player uses their echolocation. We hope that these additional features make the game more enjoyable to play, to gain more users, to study how people use and adapt to our echolocation technology.